general relativity step by step. And my goodness me, there are quite a lot of steps here. What am I doing here? I'm multiplying out the final two terms in the expansion of the linear approximation to the Einstein field equations. I've got two terms here from factorizing the Einstein tensor. We've got 1, 2, 3, 4 terms downstairs for the Riemann-Christoffel tensor. So I've got 8 terms altogether. 2 times 4 is 8. And I've done the first 6. And now all I have to do is to do the last 2. So it's plus a half. The sign changes after the first 2 elements. Plus a half. What have I got here? I've got beta and nu. I'm going to use some snazzy colours here. Let's try yellow. Beta and nu are the same here and here. So these two terms come together to form the trace of h, which I'll write on the right hand side. H. These gamma and sigma is free as always. That's free, so those appear on the right hand side as gamma and sigma. And what's my operator? Well, my operator is contracted on two things. Actually, I'll use a better colour. It's contracted on two indices. We've got alpha and mu here. Actually, I'll deleted the alpha as well. We've got alpha and mu here, and we've got alpha and mu here. So basically what that means is I'm going to just expend one of them. I'm going to use one of the alphas to raise that index there. And we've got a mu left over, so we've got a di mu on the top and a di mu on the bottom, which is quite nice. Got a di mu and di mu. The mu's coming from this mu here and that mu there. Yeah, we're just raising that operator there, and it's turning into a mu on the upstairs. That's quite nice. Am I still in black? Yes. Plus 1/2, and we're going to apply the same trick here. I'll use some better colours. Let's try green. Alpha and mu, aha, that one and that one are the same. So we've got the same story here. We're looking at the trace of h, which is there. We've got eta, gamma, sigma on its own, which is this one here. And I'm going to apply the same trick. I'm going to raise one of these terms here, that beta. No, use a better colour. If I can. Excuse me. Use a nice orange colour. That beta there is going to raise that one there. And we've got a di nu down there, but of course it's a numeral index, so I can call it what I like. I'm going to call it not sigma. I'm going to call it mu to match this one. Oh dear, what a magnificent set of algebra here. Very, very error prone. As I keep on saying, it's very, very easy to make mistakes here, and I've done this notionally the same task about 7 or 8 times now. So this is take 8 or 9 or something crazy. Right. Well, it's only been 3 minutes, so I'm going to rephrase this one here. I'm going to have a look at that one just in isolation. No, I'm not. No, I'm not. I'm going to leave that one on its own. It's this one I'm going to change. What I'm going to do is I'm going to re-express my mu. I'm going to re-express that thing there. I'm going to re-express di mu as di, let's call it pi mu, no, eta pi mu di pi. That thing there is just a re-expression of di mu. I think actually I'm going backwards and forwards here, because in order to write that mu down, I've already done it. I've already got it here, but it's as well to simplify it as much as we can. And then what I'm going to do is fool around with this. What I'm going to do is to fool around with this term here to make it look like this one here. Okay, and then I've got eta. I'm going to re-express this di beta here with in terms of a di. I'm running out of letters, aren't I? Alpha, beta, gamma, delta, epsilon, zeta, eta, theta. I'm going to call it a theta, and what was upstairs? It was a beta, wasn't it? Multiplied by h, and on the bottom we had beta mu. Beta mu. That's right. Let me get my red pen out and I'll show you why it makes sense. That beta is contracted on that there. That mu is contracted on that mu there. So I'm just doing a consistency check that my summation variables appear one in the downstairs and one in the upstairs position. Now here comes the clever bit. What I'm going to do is I'm going to use that term there to raise that index beta, and I'm going to use this eta here to raise that mu there. I don't think orange and blue look particularly nice together. So I'm going to go back to black, and what have we got left? Well, we've raised the indices, h, we've raised the index, so we've got a theta and a pi there, and we've got a di theta on the bottom from here, and a di pi on the bottom from there. Is it a half, this symbol? Is it a half? Yes, it is. It's minus equals minus a half times this lot. So now, I'll do this in red, we can see that this term here is the same as that term there. All I've done is I've got gamma and I've got beta and mu here, and I've got theta and pi here. So they're the same, in the same way that these guys here are also the same. So now I can coalesce these two terms together, or two pairs of terms, in fact. Let me go back to black. And instead of minus a half, we've got minus eta gamma sigma di beta di mu h beta mu. Of course, I've called them different things here, but it doesn't matter. It's the same thing. And now the sign has changed. We've got a plus, and these two terms are the same here as well. Di mu downstairs. Eta, actually I'll put the eta outside. Eta sigma di mu. Remember, this is a scalar operator here because of summing over mu. Scalar operator acting on a scalar thing, the trace of h. Whoo! Wonderful. Right, I'm going to stop there. Stop.